morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to multiply and divide rational expressions. So let's get right to it. When you want to go ahead and multiply rational expressions, you want to, number one, completely factor the polynomials in both the numerator and denominator first. Number two, you want to then cross-reduce by canceling out common polynomials from both the numerator and denominator. Remember, common polynomials include common exact monomials with another common exact monomial, exact binomial with an exact binomial, exact trinomial with an exact trinomial. Remember, you cannot cancel out individual terms of polynomials. Okay, next and last, once we've got that out of the way, you're going to go ahead and multiply the numerators of each rational expression and multiply the denominators of each rational expression, and you're done. So let's get right to it. Number one, let's go ahead and factor the numerators here. What times what is negative 6, but when added together is positive 1. That's x plus 3 times x minus 2 divided by x minus 5 times, we've got over here a difference of squares, so that's x plus 5 times x minus 5. And down in the denominator, what times what is positive 3, but when added together is positive 4, x plus 3 times x plus 1. So we have factored out the numerators and denominators. Step 2, let's go ahead and cross-reduce by canceling out exact polynomials. So this x plus 3 in the numerator can cancel out with this x plus 3 in the denominator. This x minus 5 in the denominator can cancel out with this x minus 5 in the numerator. And now, step 3, multiply the numerators together and the denominators together. So I've got x minus 2 times x plus 5 divided by x plus 1. If you wanted to expand on that answer and they asked you to, you can of course FOIL the numerator and you would be left with x squared plus 3x minus 10 over x plus 1. Either one of these is accurate, but we're going to go ahead and stick with the factored form of the answer for these lessons. All right, so let's move on. All right, let's check out B. We've got x minus 3 over 5 times, I can factor a 5 out of this numerator. So I've got 5 times x plus 7 divided by, this is a difference of squares, so I've got x plus 3 times x minus 3. Now I'm going to go ahead and cancel out any common polynomials from numerator to denominator. So I've got an x minus 3 in the numerator and an x minus 3 that cancels out in the denominator. 5 goes into 5 one time, 5 goes into 5 one time, the 5's cancel to 1 as well, and I've got x plus 7 divided by x plus 3. Let's go. All right, next. I can factor out a 2 GCF here, so I've got 2 times x plus 4 divided by what times what is negative 4, but when added together is positive 3. That would be x plus 4 times x minus 1 times, I can factor a 7 GCF out of that numerator, giving me 7 times x minus 1 divided by, I can factor out a 6 from this denominator, giving me 6 times x plus 5. Now I'm going to go ahead and cross-reduce. So 2 goes into 2 one time, 2 goes into 6 3 times. X plus 4 in the numerator and x plus 4 in the denominator can cancel. X minus 1 in the denominator can cancel out with the x minus 1 in the numerator, and I will be left with 7 over 3 times x plus 5. Excellent. All right, let's move on. Now, we're going to learn how to divide rational expressions. When we're dividing rational expressions, you want to go ahead and remember the good old complete the division process called stay, change, flip. Remember, the first rational expression will stay. we're going to change the sign from division to multiplication, and the second rational expression is going to flip. Then we're going to go ahead and multiply rational expressions like normal. Completely factor the polynomials in both the numerator and the denominator. Then we're going to go ahead and cross-reduce by canceling out common polynomials from the numerator and the denominator. And then last but not least, we're going to multiply the numerators of each rational expression and multiply the denominators of each rational expression. All right, so let's get right to it. First things first, stay, change, flip. So we're going to stay. First rational expression stays the same. Change. And then the second rational expression flips. That's the first and most important part to get our setup correctly. Now we're going to go ahead and factor the numerators and the denominators like regular rational expression multiplication. Remember that you can factor out a -1 here, so you can have a positive leading coefficient. So that gives me -1 times x minus 2. What times what is 1, but when added together is 2. We've got a perfect square here, x plus 1 times x plus 1 times, we've got a difference of squares up here in the numerator, so this is an x plus 1 times an x minus 1 divided by what times what is 10, but when added together is, I wrote that incorrectly. That should be x squared plus 3x minus 10. I apologize about that. We're all human. So let's go from the beginning. What times what is -10, but when added together is +3? That's going to give me x plus 5 times x minus 2. All right, excellent. Now let's cross-reduce. So I can cross-reduce this x minus 2 in the numerator with this x minus 2 in the denominator, and I can cancel out one of these x plus 1s in the denominator with this x plus 1 in the numerator. And I do not have any other identical polynomials that I can cancel out, so I am left with negative x minus 1, be sure to keep that in parentheses, over x plus 1 times x plus 5. All right, let's go. All right. Oh no, don't be afraid of this. Just stick to the procedures. So let's go. Stay. Change to multiplication and then flip. Speed comes with practice, remember that. And I see that I made a little error here. Please change this 24 to a 42. Please change that 24 to a 42. And I apologize. All right. So now we went ahead and stay, change, flip. Please make sure that you catch that error that I made with the 42. And now let's factor the numerators and the denominators. So what times what is 7, but when added together is 8. We've got x plus 7 times x plus 1 divided by what times what is -12, but when added together is -1. We've got x minus 4 times x plus 3 times what times what is positive 24, but when added together is -10. We've got x minus 4 times x minus 6. And last but not least, what times what is -42, but when added together is +1. We've got x plus 7 times x minus 6. And now we're at the fun part. We're going to go ahead and cross-reduce. So this x plus 7 in the numerator cancels with this x plus 7 in the denominator. This x minus 4 in the numerator cancels out with this x minus 4 in the denominator. This x minus 6 in the numerator cancels out with this x minus 6 in the denominator. And we are left with x plus 3 over x plus 1, over x plus 3. All right. Sometimes I get jumbled up, so sometimes just take your time, take a deep breath, and go a little slower if you need to. Remember, you can always pause this and rewind and rewatch it. All right, next. First things first, whenever I see a polynomial just by itself, I go ahead and place that invisible 1 underneath it. So now I can differentiate between numerator and denominator much easier. And we are dividing rational expressions, so we are going to stay. And we're going to go ahead and change the multiplication and flip. Notice how that 1 comes in very handy there. So please notice that. All right? Putting that invisible 1 there really helps differentiate the numerator and the denominator. All right, let's get back to it. So let's factor what times what is -7, but when added together is -6. We've got x minus 7 times x plus 1 divided by, this is a difference of squares, so I've got x plus 5 times x minus 5 times 1 over x minus 7. I can go ahead and cross-reduce the x minus 7 in the numerator with the x minus 7 in the denominator, and I am left with then x plus 1 over x plus 5 times x minus 5. Let's go. All right, let's wrap it up here. Let's just do a few more just to practice. Find the quotient or product of each in simplest form. All right, I did this on purpose because I don't want you to freak out when you see this. Please remember that this is just a giant division bar, okay? This is my numerator being divided by my denominator. So since we are dividing rational expressions here, we're going to stay, change, flip, just like before. So let's do it. Stay, change the multiplication, and then flip. Now let's factor those numerators and denominators. I've got 12x over, I can factor out a 5 here from the denominator. Times we've got a difference of squares up here in the numerator, x plus 4, x minus 4, divided by a 4x squared. All right, so let's see what we can do here. 4 goes into 4 one time. 4 goes into 12 3 times. X divided by x squared is x to the first power down here in the denominator. And x plus 4 in the denominator cancels out with x plus 4 in the numerator. So my final answer will be 3 times x minus 4 divided by 5x. All right, let's get it. All right, next. All right, we're dividing rational expressions. Let me go ahead and delineate this. So we've got stay, change, flip. Now let's go ahead and factor. I can factor from this numerator a 5, giving me 5 times a minus b over 7c squared times 21c over, I can factor out a 10, and that's going to give me, sorry about that, I can factor out a 10, and actually, look at what I noticed. If I factor out a 10, I'm simply going to get a 10b minus a. And that's not really what I'm looking for. I'm looking for an a minus b. So let's go ahead and notice that we can factor out a negative 10, giving us now an a minus b. That makes a lot more sense. So now, 5 goes into 5 one time, 5 goes into negative 10, negative 2 times. 7 goes into 7 one time, 7 goes into 21 3 times. A minus b cancels out with the a minus b in the denominator. And of course, c divided by c squared, you're subtracting exponents. So this c cancels. I've got one c left in the denominator. So my answer would be 3 over negative 2c. And we always want to bring that negative up to the numerator. So we've got a final answer of negative 3 over 2c. Let's go. All right, two more. All right, we're just multiplying here, so let's get right to factoring. What times what is 2, but when added together is 3. We've got an x plus 2y, remember there's a y squared in the back end, times an x plus 1y. Divided by, I've got a difference of squares, x plus y, x minus y, times, I can factor out a 3 here, GCF, x minus y, divided by, I can first factor out a 9 GCF here, giving me x squared plus xy minus 2y squared. And now I can factor this right here. I can turn this into a 9 times x, y, x, y. What times what is negative 2, but when added together is positive 1. Got a positive 2 and a negative 1. All right, now let's get to the fun part. This x plus 2y in the numerator cancels out with this x plus 2y in the denominator. This x plus 1y in the numerator cancels out with this x plus 1y in the denominator. This x minus y in the denominator cancels out with this x minus y in the numerator. 3 goes into 3 one time, 3 goes into 9 3 times, leaving me with 1 over 3 times x minus y. See, it looked complicated, but it's not that bad, you got to admit. And last but not least, wanted to give you this opportunity to remember this skill again. We've got 2x minus 3 over 3 divided by 6x minus 9. Go ahead and put that over 1. Because now when you stay, change, flip, you can clearly understand what your numerator and denominator is. So I've got to stay, change, and then flip. I've got here 2x minus 3 over 3 times 1 over, I can factor a 3 out of here, giving me an x minus, giving me a 2x minus 3. And then I can go ahead and cross reduce. The 2x minus 3 in the numerator cancels out with the 2x minus 3 in the denominator, and I'm left with 1/9. Let's go. Now you know how to multiply and divide rational exponent expressions. Hope you learned a lot. Thanks for watching. Come back anytime. Take care now. Bye-bye.